Hello and Happy New Year, everybody. I'm Colin Breckles with Castlebeck. Heiko?
Heiko Voigt from Harborlight Software in Halifax. Over to you, Graham.
Yeah, Graham Akers from Brightech Systems in Vancouver. Welcome to our C3UG video. Colin, what's our topic today?
Well, today we've got John Curtis with us talking to us about DQL, Domino Query Language. John is the Chief Application Development Architect at HCL. Job titles are in flux, we understand, and but he's got a broad portfolio, and DQL happens to be very timely and interesting. And John, thanks for being with us today.
Glad to be here. Glad to be here. Yep.
So this presentation that you're going to do is one that you presented at Collabsphere in Boston in October, and there's been some new improvements and stuff since then, and of course V11's been launched, so we'll let you take it away.
Okay, let me share my screen here. Share the entire screen. Yep. Okay. So let me bring it up. All right. So yes, as it was said, this is a clone, a little bit changed from the presentation I gave at Collabsphere in Woburn, Mass. A few months ago. We are moving forward. I tell people I wrote a blog entry called My Demos Crash, which really talks about the fact that I try to present things as they happen, as they go out, which means they're cutting edge, and so they don't necessarily demo well. I do present this presentation with good demos though, so I prepare for that. But yeah, we're talking about DQL, and Domino 11 is the second release of DQL. We rounded the language out, and I'm going to talk about the future of DQL thereafter because we have a very ambitious plan coming forward. So without further ado, let's go. What we did with DQL was we brought in a new operator. We had in version 10 two of the three different ways to find documents in Domino. We had NSF scanning, and we had view entry scanning, view entry lookup, which people are used to. In 11, we completed that by putting in full text searching as part of DQL. And there are two flavors. The contains operators, how it's being done. Contains says, not equal by the way, contains says this field has the following text in it. So in this case, I give you two examples. The body field contains, and I would standard issue that phrase, or, and you can see right here, we have support for the wildcarding notebook. Okay, I'm looking, or notebooking, anything that has any two letters, a question mark is single, wildcard, the asterisk is any number of wildcards following that. The contains operator below that is a document level contains. So that says any field in the document contains any of these. It's a hit, basically. So this operator goes along with any of the different operators in the DQL language. You can and or and put things around it, that sort of thing. And it does, as I said, perform a full text level search. Okay, that's what it does. A database level full text search finds terms embedded either in a field or in a database, and I give you some examples below. This is, the set of kind of things you can do. Dollar file, you may know, is the attachment label. This is kind of the, if you want, anchor text of attachments. So this finds the PDF type. So these are working queries in DQL that find things. And as I said, if you have a field name, it will limit that. If you don't have a field name, it's very much like the in clause. We have an in clause in DQL that either takes a field or performs things at a document set level. Okay, same idea. Okay, now there's some modifiers here. One is to say, if you say the word all, that is essentially an and that says I want to take everything in this list that I gave you, and I want to make sure they're all in the found set I want. So if any term in the contains list will have to be found for it to be a hit. Of course, you must have a full text index on the database, and this will not create the full text index on the database. So if there's some administrative setup to be done, perhaps, if we haven't got one. As I mentioned, it does support wildcarding. The two different wildcards are supported, the asterisk, which is any number of wildcards of characters, or the question mark, which is a single character. and this already came up in beta that you cannot dangle wildcards. So that in this case, I give you the word space star. We'll find nothing because it doesn't handle that. Okay. Now it has to be said that it's not the same as field equals value. Okay. People will say, but I can use it that way. Yes, you can use it that way if you know your data. But for instance, if you try to find the term, the phrase everyday data, okay, and you look for the word every day, you will find it. But you will not find everyday. The everyday data will not be found via every day in the field equals value case. So you understand it. It's finding a set of text within a larger body of text. If you have a field that has, and you know that the full text value of that field, sure, you can use contains to do that. But know your data is the mandate. Right now, we only do text values. Numbers and dates are coming. We haven't got that ready yet, so it's on the way. There is, and this is important, there's a new option for execute and explain of the Domino Query object, which says, I want you to refresh my full text index prior to the query. This has been an issue for full text search for quite a while. This works very, very well with DQL. So you're guaranteed to have up-to-date full text indexing for your searches. Okay. Okay, let me show you how it works here. I think this one's here. So I'll just run a contains demo, and I will do one of these. My demos are going to run as they run. I'm going to show you results as they commence. This is the classic cooking show on TV where they put something in the oven and then show you concurrently the results. So here we go. This is what I'm going to be running, and you can see it takes 5 seconds or so for queries. I don't want to watch. We can sit and watch that, or I can just do this. So what this is doing is basically saying this is existing Domino 10 syntax, saying I want you to take and find these values of the salesperson. Okay, that's what I want you to find. And you see it goes through these things, and it uses a view lookups, about 55,000 entries apiece, taking about 1.8 seconds each to come back with a set in 5 seconds or so. So there you have that. By the way, this is I think it's a, I'm not sure how big the database is. Yeah, this is right. This is my 2 million document database. Okay, so that is using the in clause. Contains then, okay, it does the same thing because I know these are the values. Again, I mentioned how you would have to know your data. I know that Trudy Ayton is a full value in the salesperson field. So I will use these to look up in full text. So that's what it finds. And you can see that we are, in fact, doing, yeah, this is spanning pages. That's okay. We're doing it, and the explain output says it ran full text. And you can see that it runs quite a bit faster. It took 1.1 second for the whole thing. It took about 5 seconds for the other one. So it's between 4 and 5 times faster. And there's the bottom, the same number of documents found. So you can see that it's finding the exact same values. Okay, so let's go down to the next thing, and we're going to look at the order status field now. This is where you really start seeing the cost. So order status is a high cardinality field. Okay, so there's a lot of documents with these values. You can see we're walking 399,000 entries in NIF. This is the view search. Okay, so that's not cheap. That's going to take 13 seconds and 12 seconds for the other ones, a total 26 seconds, and it finds 800,000 documents. So that's a big found set. So let's see what we do with full text on this one. It's quite a bit faster. It went down from 25 to about 5 seconds. And it does the same thing, full text searching. Again, finding the same number of documents, and it's faster. So let's take that query and then take it down and decorate it with some wildcarding. Okay, so shipping, I replaced the P with a question mark. Procurement, I just put a star in there, so it's 0 to N matches there. Find the same document set in about the same time. There's no real penalty for using wildcards, which is not true of many engines, by the way. Wildcarding does slow a lot of things down that way. So here we go with even some more wildcarding. I get rid of procure and do that up. Again, we haven't seen much of a degradation in how fast it runs. It's 5.1 seconds, and it found the same set of documents. And then just to complete the perversity of this whole thing, I get rid of the P, and so leading wildcard doesn't even slow it down. So that's something you don't see in a lot of engines. It's a nice part of the GTR engine in its n-gram approach, that we don't necessarily get any kind of a penalty for using wildcard. So you get the point that you can do this. And by the way, I will say these timings that you're going to see in my demos this morning, these are running non-production code, which you will never see. We run it because it finds issues before you ever see the code, and it's running on my laptop. So this is laptop speed. You can expect, if you run Domino on a laptop, to get these kind of results. Okay, and the last one, again, I'm just doing the same set. And this case, I showed the dangling asterisk, okay, which finds no documents. See that space there? That basically shuts off, and that doesn't work. So this limits the found set quite a bit and cuts down on time, but I made a mistake. I don't want that in there. So wildcards cannot hang on the end like that. That demonstrates that. Okay.
So one of the things that you're illustrating here, John, sorry to interrupt there. One of the things that you're illustrating here is to do multiple iterations in your testing and be able to compare, like the explain here that gives you the details of how long it took to run and the number of documents returned, let you see that you're making a mistake.
Yes. Thank you. I'm probably the most experienced DQL programmer on earth. So I would hope so, by the way. But no, that's a explain is your buddy, okay? And I will tell people learn explain, okay, because it will help you understand what the engine is doing. It will help you tune your queries, and you'll be able to come back with a set of documents to see if you have issues, what is going on. You see it breaks down the query terms into the individual execution. So if I ran this procure thing and didn't see any results, well, this tells you, okay, that's why, okay, it's not going to return anything. When above, I have the exact same thing with the asterisk attached to it, and I found 802,000 documents. 800,200 documents. Okay, so there's a lot in explain to be gone into. I'm not really going to dive onto it. I have in earlier presentations, and I'd be glad to in a future date or some other venue explain. So that's how it works. All right, let's go back into the presentation then. Okay, so there's a demo. Excuse me. The next thing we did was really attack the design catalog as an approach. In Domino 10, we delivered, what this is, first of all, let me go back. What this is an optimized copy of design data. We do not want to be opening view notes during query compilation execution to find the best way to do things. So we made an optimized copy of design data so that we can do it quickly at runtime. And in version 10, we created a separate database called gqfdesign.cat. So dzgn.cat. If you ran Domino 10, you saw that was necessary. If you didn't see that, you didn't have a design catalog. Well, we brought that inboard inside the database. We used a combination of name notes and ghost notes. You never see them. They won't show up in any view. I will say that the field names do show up in Designer. We're looking to get rid of that, but you never see these notes is the point. Updal-E and -D work as they did in Domino 10, but there is now it's very easy now to rebuild or refresh your design catalog with explain and execute query. We actually have a new parameter on those two calls to do it for you. So I listed two properties below in LoadScript and Java. You either say get or set. The get set are Java variants, but without those you have the LoadScript variants. You set these or get them to see if you are in fact rebuilding or refreshing your design catalog. So this is excuse me. Rebuild means I want to blow it away. I want you to destroy and recreate it. The refresh says if anything has changed, I want you to refresh it. Refresh will also create on first time. By the way, I should say that rebuilding this, I have not made a design catalog run take longer than about half a second. And that's really that's an outlier. Usually it is 10 milliseconds or less. It's very fast. So I don't, just to give you a scheme of things here. Okay. So the other thing we heard, and this was really talking to people about what they were seeing with the DQL indexes, actually use of views. What we heard and saw was that it's really hard to create a view that's useful to DQL. There's a lot of different things. For instance, we had to permute values, so make sure all your values are in fact, click that button that says I want every value broken out, because it has to be equivalent to the NSF scan, which does exactly that. So this is how we, Domino supports lists, right? And that's something that not a SQL database does not support. So we need to have a common way of expressing that, and that way was to permute the values. That's just an example. There are 3 or 4 or 5 more values that had to be checked inside Designer to make your view palatable and useful to DQL. So we said, well, that's way too hard. Let's stop that. So what we did was we said, we're going to create indexes. Now, indexes are views. I will say that. They're views that get created as part of the process, but they're skinny. Now, what do I mean by skinny? Well, I mean that they have a single column. That is, you may know that when you create a view, everything that gets displayed, whether it's sorted or not, it pulls in data into the index and keeps that data around for when you browse through it, when you traverse that view. Well, in this case, we have a single column. We found that to be 40% faster, at least, than a regular traditional view it's not skinny. That's a larger, a corpulent view, put it that way. Yeah, so we had that, and that is what gets created. There are 3 calls that are attached to the Domino Query class: create index, remove index, and list indexes. They're very powerful. Okay, and I will tell people, you're creating views when you do this. Okay, and you need to have designer privileges, of course. But my job is to make people powerful, but with power comes responsibility. So use these with caution. Make sure you're doing the right thing. Don't just willy-nilly create views. I think we've seen it's very easy in Domino to create views, and that's a good thing and a bad thing. People have had enormous amounts of wasted views they had to later revisit. I'm going to talk more about views later on. By default, these are hidden views. The name is enclosed in parentheses. You won't see them unless you open the view with to see hidden views. Everyone knows about. I think everyone knows about the Control-Shift-Open to see them. List indexes is a way. Excuse me. So create and remove, I think, are self-explanatory. List indexes outputs JSON. Okay. People say, what's in my catalog? Well, you can find out by running list indexes. That produces it. And that will show you, and I'll show you the output of that in just a minute. But that shows you what is in the catalog, what you can use, both in terms of, there's 2 syntaxes, right? There's the quote view name dot column name and the field name. And it tells you which of those are useful. List indexes does not just report on those things created through create index, but on all views that are useful, all views in the database that are useful to DQL. Okay, so that's part of what it does. Also, if you want a more programmatic way to look at what is indexed, to actually walk views and view columns, we have new attributes on the view column class for column and field. Again, there's 2 different. There's read only. We're not going to let you update because it's not. Again, you update these things by modifying the view. So to examine them, we show you those 2 attributes again, whether it's useful for a view syntax or a field syntax. That's what happens there. Okay, so let's look at this capability. First of all, I'm going to start my Domino server so you can get that going here. This is my. Okay, let me run this first. So what this is doing is copying 10,000 documents. This is a small little database. It has no views, which I'll show you in just a minute. It runs this, and then it runs updal-e. Updal-e will create the design catalog, but you notice there's nothing in it. Nothing's in it. This has no views whatsoever. So I will now run the the actual demo. This is going to create, I'll show you the Java code it's running. So I'm running that in the background and show you the Java code that's running so you can see it. Yeah, I'm sorry, this is, yeah. Okay, so here's the Java code it's running. Here, so moving up. Right, so let's go through this. The first thing I do is list indexes. So list index call, right there, that index string right there. It's a JSON output, so I'm using the Google JSON class to actually pull it apart and display it. And then what I'm doing is I'm running a bunch of explains, and I am creating indexes to make them go faster. Now, you can tell that I'm a developer because they don't always go faster, because there are only 10,000 documents in this database. NSF scanning is quite fast. So in fact, it doesn't always speed it up, but I'll show you the results there so you can see what's happening. So again, going back to the, right, this is going to be in text view actually, here. Okay, good. So this is actually the output I'm seeing. And what happens is that I'm creating basically these views. So list indexes, there's the first output. Nothing. Look, man, no indexes. There's nothing in there. Okay, and then I do a bunch of creates. Okay, so I'm saying I'm going to create these indexes and run before the queries. So here we have the first one is probably the most dramatic results. We see that, in fact, this was scanning all 10,000 documents. You see that? And now, because we are able to use an index, we are now just processing the 351 hits that are part that TrueD8 has. And the reduction is profound. It goes from 231 milliseconds to 5 milliseconds. Now, you know, a quarter of a second is not going to bother anyone, which is my defense for what I'm going to follow here. So the other ones are, in fact, we do see them go from scanning to indexing. Okay, so that when you look at explain output, scan docs means NSF is being scanned, entries means NIF is being scanned. Indeed, the first one actually takes, if you see, a few milliseconds longer to run, but the idea is that if it was a larger database, you would in fact see quite a reduction in the time. Okay, so that's what happens. And then I run at the end of things, I run the list indexes. So here we go. This is the list indexes of what I've just created. So I have these 3 indexes. They have been duly created by calling create index, and they show up. And these are, walk through this, index name, which is the name of the view. The column name is a programmatic name of that column. And I said they're skinny, so there's only one. If you had a view that was not skinny, you'll have multiple column names showing up under that index name, which is the view name. Column ref means that I can use it as IDX salesperson. I can use it that way. Field ref means I don't even need that. I can just say salesperson equals and use it that way. Okay, so that's what these are. Excuse me, there's one for each. You could certainly go into NIF and go into the designer and create one view for each that has these 3 columns. But the idea is that this is a faster way to index them. I'll talk about views a little bit more later as we get into it. But then after all that, I change my mind and I throw them away. So it's that fast. I mean, if you want to create an index, run a bunch of queries and throw them away, it's fine. Okay, this is a different approach to views, right? People they say, well, that's my design. You know, I don't want to just delete it. This is saying that it's a transient design. Design, in fact, is something that gets modified. You can ad hoc change things. So each of those goes away, and in the end, we end up having the same output that we had at the beginning. This black, no indexes. Okay, now you'll see this. I don't run it again, but that's what it is. There's nothing left for indexes in the database. So I started from no views to 3 views. I increased the speed, at least on a good day. If I had more than 10,000 documents, I would increase the speed of those queries, and then I throw away the results. Okay. So that's
I have a question.
Okay, good.
I have a question
Sure,
about the overall cost from a disk space standpoint. So I certainly respect the comment that you just made about design being transient, but from a development standpoint, if I'm planning things out and you know,
Yep.
not paying attention and
It's a
get
good
kind of
question.
wildly out of control, I could
It's a good
blow
question.
up. Yeah. So what's the overall kind of on disk cost that I need to be prepared for?
Well, I think we have to. So this is going to be something we all come to understand with views, okay? And that is that I'm getting a little ahead of myself here, but the views are something that we have traditionally kept around for a long period of time. We have one of our system databases. In fact, the SPR database is one that has some 650 views. 20 of which are used.
Yeah.
So
yeah.
I'm not impressed that people have done due diligence on this now. But yes, we are creating great power here. It is powerful, that third bullet, and that requires you to think about it. Yes, what is the cost? Of course, this is part of what we do here. The idea is to be equitable in your discussions. The point is, though, that you do want indexes in some cases. That's what you need. In other cases, you don't need them. So it's going to be hit or miss. It's going to be learning on the way by, on the fly, and finding out what's best. I presented this in this way so you can see, well, you don't have to keep them. Okay, so you can expend the resources to run a set of queries at night or over the weekend, whatever, to do a bunch of reports and toss them. Okay, there's nothing wrong with that. And that's really, that I'm taking, and I think you'll see as we continue to present this, the approach to the whole view paradigm is changing in Domino. That is, as far as we're concerned with the back-end classes and views. Okay?
It's the same notion as what we're seeing. It's the same notion as what we're seeing in cloud spaces, right? Where Amazon or Azure or whatever says, yeah, you can spin up the resources when you need them, and then spin them back down after you're done. Exact same concept.
That is the new world, right? That's right.
So one thing that comes,
so we can brag about it too.
I wanted to ask a related question. So on the same concern of not creating unnecessary views, presumably it would be a good practice to test your query execution to see what the performance is like before prematurely optimizing. And
exactly,
we're all guilty of, at initial development time, not having adequate data to load test things. So you need like a QAT or an integration test environment that has appropriate data volumes, perhaps sanitized to have personally identifiable information removed, so it's still real data. Just wondered if you've already got your head around that, and if there's any emerging best practices.
Yeah, so that's the very reason we invented Explain, right? So you can run Explain and see how long something will take without even putting into production. Okay,
right.
So what is your SLA? What do you need to have? Think time. Is it 5 seconds, 2 seconds, 1 second,
right.
Whatever it is, you can conform to that by running your query. And with the contains operator and the ability to use the full index, I'm pretty confident we can do just about anything as far as that's concerned. It's a matter of what you want to create, what you decide to do here. So let's take that as the way it goes. Okay.
Okay.
So and Explain, it will it gives you a single query as you run it in isolation. Of course, things change when you run them with multiple threads.